Have you ever wondered how tsunamis form? These massive towering waves can travel across entire oceans, leaving destruction in their wake. But what exactly causes a tsunami? Why do they happen? And how do they grow so powerful? Today on Science by PK, we'll dive into the fascinating and terrifying science of tsunamis. Stick around to the end and make sure to like, subscribe, hit the notification bell before we continue. First, let's get one thing clear. A tsunami is not just a regular wave. Regular waves are caused by wind moving across the surface of an ocean. A tsunami, however, is a wave caused by the sudden displacement of massive amounts of water, and it involves the entire depth of the ocean from surface to the seafloor. This is why tsunamis are so powerful. They move enormous volumes of water at once. In fact, a tsunami can travel at speeds up to 500 miles per hour in the open ocean. That's as fast as a commercial plane. So how do tsunamis form? The most common cause is underwater earthquake. When tectonic plates in the Earth's crust shift or collide, the seafloor can either rise or fall abrupt. This movement displaces an immense amount of water, which ripples outwards in all directions. Imagine dropping a rock into a still pond. The ripples spread out evenly, but on the ocean scale, these ripples are as massive and incredibly energetic. But earthquakes aren't the only triggers for tsunamis. Underwater volcanic eruptions can also displace water when a volcano erupts. It can cause sudden explosion or collapse, pushing water away from the eruption site. Similarly, when water landslides caused by collapsing slopes on the ocean floor can shift water, suddenly generating a tsunami. Even meteorite impacts tsunamis, although it's a rare case, but they can also create tsunamis if the impact occurs in an ocean. Essentially, anything that causes a rapid displacement of water can trigger a tsunami. Once a tsunami is triggered, the way it moves across the ocean is fascinating. In the deep ocean, tsunamis are barely noticeable. They might be only a few feet high, and their long wavelengths make them seem like gentle swells. But as the tsunami approaches a shallow coast water, it slows down, and when the wave slows, all that energy is compressed, causing the wave to grow dramatically in height. This is why tsunamis near the shore can reach towering heights of 30 feet. Or even more during extreme events. These waves don't just hit once, they come in a series called a wave train, with each wave potentially being larger than the one before. Most tsunamis occur in the Pacific Ocean, especially along the Ring of Fire. This region is a hotbed of tectonic activity, where massive plates of the Earth's crust are constantly moving, colliding, and shifting. Countries like Japan, Indonesia, and Chile are particularly vulnerable to tsunamis because they sit near these active plate boundaries. However, tsunamis aren't limited to the Pacific. The Indian Ocean and even the Atlantic Ocean have seen their share of devastating tsunamis, such as the 2004 Indian tsunami, which claimed over 230,000 lives across 14 countries. The impact of the tsunami is often catastrophic. When a tsunami hits hard, it brings with it an immense force and energy capable of flattening buildings, uprooting trees, and washing away entire communities. But it's not just the towering waves that cause destruction. Tsunamis often create storm surges, where seawater floods inland, and heavy flooding can remain long after the waves recede. This flooding can destroy crops, contaminate freshwater supplies, and leave behind layers of mud and debris, making it even more difficult for recovery. One of the deadliest tsunamis in history was the 2004 Indian Ocean tsunami, which was triggered by a massive 9.1 magnitude earthquake off the coast of Indonesia. The waves traveled across the Indian Ocean, reaching as far as East Africa. Entire villages were wiped out and millions were left homeless. The sheer scale of the destruction showed how devastating tsunamis can be. Now let's talk about how we can detect and predict tsunamis. Advances in technology have made it possible to track tsunamis and issue warnings before they reach land. Seismic monitoring stations detect underwater earthquakes, while ocean buoys measure changes in water levels. When an earthquake capable of causing a tsunami is detected, warning systems can alert nearby regions. However, the challenging part is the time. Since tsunamis travel so quickly, people in affected areas only have minutes or hours to evacuate. This is why education and preparedness are so important in tsunami-prone regions. So what should you do if you ever find yourself near a coast and a tsunami warning is issued? First, don't wait to see the wave. Move to higher ground immediately or as far inland as possible. If you notice the ocean suddenly receding far from the shore, it's a major warning sign a tsunami wave could be on its way. Pay attention to the alerts and stay away from the coast until the authorities say it's safe to return. Tsunamis are a reminder of how powerful and unpredictable nature can be. They focus on the powers nature has, but they leave impacts that last for generations. Understanding the science behind tsunamis helps us prepare these disasters and save lives. If you found this breakdown of tsunamis fascinating, don't forget to like this video, subscribe to Science by PK, and hit the notification bell so you never miss out on a new episode. Let us know in the comments on what natural phenomenon you would like for us to explore next. Thanks for watching and stay curious.